Hello students, welcome to the world of chemistry. This is Dr. Vikram Panchal and this is lecture number 17 in the series of chemical kinetics. Okay, I'm discussing this numericals of second order. So one more numerical, prove that the following reaction is of second order. Reaction is HbRO3 plus 6Hi gives HBr plus H2O plus iodine. Okay, you have to prepare set for this. The set 1, bottle number 1, take 25 ml of 0.1 normal KBrO3 and 100 ml 0.1 normal HCl. Bottle number 2, take 25 ml 0.1 normal Ki and 100 ml H2O. Well, mix both models, both the solutions, and take 25 ml mixture for titration. Against 0.01 normal Na2S2O3 solution using starch as an indicator. The table is given, time in minutes and burette reading, which is X ml. So after 5 minutes the reading is 6.8, 10 minutes 9.3, after 15 minutes 11.1, after 20 minutes it is 12.3, after 25 minutes it is 13.2, and after 30 minutes it is 14.4. Okay, now we have to prove that this is of second order. Okay, now let us start. First of all, we have to find out A and B. So calculation of A and B. Look, when we mix both all solutions, the total volume will be 250 ml. Okay, now effective concentration of KBrO3 in total volume. For that we write N1V1 is equal to N2V2. N1 is 0.1 molar. We are taking 25 ml of the mixture. Now total volume is 250 ml. So N2 will be 0.1 into 25 upon 250, which is 0.01 normal KBrO3. So this is the effective concentration of KBrO3 in total volume. Okay. Now let us calculate small a, that is the volume of KVRO3. So for calculation of a, we write N1V1 is equal to N2V2. Okay, N1V1 is for KVRO3 and N2V2 is for sodium thiosulfate, which we take in burette. So here N1 is 0.01 normal of KVRO3. We will pipette out 25 ml of the solution. The concentration of sodium thiosulfate is 0.01, which is given, and V2 will be small a. So V2 is equal to 0.01 into 25 upon 0.01, which is 25 ml, and this is small a. Now, effective concentration of Ki. Effective concentration of Ki in total volume. Again, N1V1 is equal to N2V2. We are taking 0.1 normal Ki and 25 ml of Ki, which is equal to N2 into total volume 250. So again, N2 will be 0.1 into 25 upon 250, that is 0.01 normal Ki. This is effective concentration of Ki. Now we have to find out B, small b. So for calculation of small b, we again write N1V1 is equal to N2V2. Here N1V1 is for Ki and N2V2 is for Na2S2O3. The effective concentration of Ki is 0.01 normal. We are taking 25 ml of the solution. Concentration of Na2S2O3 is 0.01 into V2, that is small b. So V2 is equal to 0.01 into 25 upon 0.01, and that is again 25 ml. So this is small b. Now here, by calculating both this small a and small b, we came to know that A is equal to B, and therefore the formula will be K is equal to 1 upon 80 x upon A minus x. This formula we will use to find out K, and if all K's are same constant, then we can say that it is second order reaction. So for that we are preparing time table. Time, first of all, time, that is 5 minutes, 10 minutes, 15, 20, 25 minutes and 30 minutes. X, that is burette reading, is given 6.8, 9.3, 11.1, 12.3, 13.2 and 14.4. You know A is equal to B is equal to 25. So you are given 25 and you know X. So then you can find out A minus X and then K. K is equal to 1 upon 80 X upon A minus X. So find out A minus X for each one, like here 25 minus 6.8, in this case 25 minus 9.3, 25 minus 11.1, 25 minus 12.3, 25 minus 13.2, and here 25 minus 14.4. And then for 1, K1 is equal to 1 upon 25 into T, that is 5, X is 6.8 upon 25 minus 6.8. Okay, for this we can find out K2, K3, K4, K5, K6. And if you get K1 is almost equal to K2 is almost equal to K3 is almost equal to K4 and all that, then we can say that the reaction follow. second order. So this way, with the help of this all data, we can find out that the reaction is of second order. Okay. Thank you so much for this lecture.